Good morning, this is Dr. Turner for Fundamental Mathematics. Today we're going to be covering 8.3, which is looking at combined probability. Specifically, we're looking at probability that is either mutually exclusive or non-overlapping, also known as non-mutually exclusive. So the assignment today is looking at the probability where we are looking at more than one event potentially out of the same sample space. Question is, are the two events mutually exclusive, which means there's no overlap, or is there overlap? Is the question. And we'll see that here in just a second. So to start out, let's look at what these two things are. The idea is that when we look at probability of more than one thing, you have either mutually exclusive, which as the name might suggest, means that they are not overlapping, or you have non-mutually exclusive, which means they are overlapping. So what this means, in the first example, we're looking at two events and there's no common ground. They're completely separate. They're not sharing anything in common. Whereas the second one, potentially, they are overlapping, which means they do potentially have something in common. For mutually exclusive events, the probability of A or B, and we use this union symbol to indicate or, is simply the probability of A plus the probability of B. So you're simply adding those two things together. Now, if you are looking at the probability of A or B where they are non-mutually exclusive, meaning that there is some overlap, this changes a little bit. The probability of A or B is equal to the same probability, A plus B, but you have to subtract the probability where they are overlapping, which is read as A intersection B. And this is basically a symbol for and. And the reason for that is you don't want to count the same event twice. So we'll look at that in just a second. Let's say we take something like rolling a single die. And let's say I ask you for the probability of rolling a 1 or a 4. Now, you don't have to write out the sample space, but we know from the 8.1 and 8.2 assignments that a die, you could have 1, 2, 3, 4, 5, or 6. So the question first is, are these overlapping? So if I'm asking you what's the probability of rolling a 1 or a 4, the question is it possible to roll a 1 and a 4 at the exact same time? The answer, of course, is no. Therefore, all we have to do is add the probability of rolling a 1 plus the probability of rolling a 4, because these are mutually exclusive events. Probability of rolling a 1 is 1 out of 6. Probability of rolling a 4 is 1 out of 6. So the probability of rolling a 1 or a 4 is 2 out of 6, or you could simplify the fraction to 1/3, like so. If I look at something like a deck of cards, and I ask you the probability of drawing a king or an 8. If I ask you to roll or pull out a card that is a king or an 8, though these again are also mutually exclusive events because it's impossible to draw an 8 and a king at the same time. Those are different cards. So this would be simply the probability of pulling out a king plus the probability of pulling an 8, because these are mutually exclusive events. There are 4 kings in a deck, and there are 52 cards. So this would be 4 out of 52 plus 4 out of 52, which is, of course, 8 out of 52, or 2 out of 13 if you simplify the fraction. So those are pretty straightforward. Those are mutually exclusive events. Non-mutually exclusive events means that there is potentially an overlap. So let's say we take a die and I ask you for the probability of rolling either an odd number or a 5, for instance. Now here there is overlap because 5 is an odd number. So if I were to just do probability of an odd plus the probability of a 5, let's say we wrote out our sample space for this one, 1 through 6. If I count my odd possibilities, that's 1, 3, and 5. And if I count my 5, well, I'd be counting the 5 twice. That's why we have a subtraction of the intersection in non-mutually exclusive events. So it's a probability of an odd number plus the probability of a 5 minus where we overlap, which means it's 5 and odd. So writing out these individually, this would be odd, 3 out of 6, plus probability of a 5, 1 out of 6, minus the probability of both, 1 out of 6, which would give me 3/6 or 1/2. Number 4, say I asked you for the probability of drawing a heart or a king. So looking at our sample space, again, you don't have to do the sample space, but if you did, you have hearts, you have diamonds, you have spades, and you have clubs. And then for your face values, you have 2 through 10. And then Jack, Queen, and King. So doing the simple probability, the hearts would give you 13 cards because there's 13 in each suit. If you look simply at the kings, there are 4, heart, diamond, spade, and club. But by doing those individually, you're counting the king of hearts twice, which is why when you go to calculate the probability, you need to subtract that overlap. So this is the probability of a heart plus the probability of a king minus the king of hearts, because you don't want to count it twice. So that would be 13 out of 52 plus 4 out of 52 minus the king of hearts, so you don't count it twice, 1 out of 52. That would give you a total of 16 out of 52, or if you simplify it, 4 out of 13. So pay attention to if there is some overlap, and depending on that, you'll use one or the other formula, very similar, but if there is overlap, subtract so you're not counting twice. That's it for this lesson. If you have any questions, please reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.